What if you could build a fully functional AI chat app with real-time streaming in just 15 minutes? No complex WebSocket setup, no juggling raw API calls, just React on the front end, Express on the back end, and Crystal SDK handling all the AI orchestration. That's exactly what we're building today. By the end of this video, you'll have a production-ready chat application that streams AI responses token by token, just like ChatGPT. Let's dive in. Before we write any code, let's understand the architecture. Our app is a simple horizontal pipeline. The React frontend sends a user message via fetch to our Express API. The Express server passes that message to the Crystal SDK, which handles the LLM call, whether it's OpenAI, Anthropic, or any supported provider. The key here is streaming. Instead of waiting for the entire response, we use server sent events, SSE, to push tokens back to the browser as they're generated. The Crystal SDK gives us an async iterator, Express writes each chunk as an SSE event, and our React hook parses those events in real time. 3 layers, clean separation, and the Crystal YAML config means the AI layer is completely declarative. Let's set up the project. We have 2 directories, server and client. The server directory contains our Express app with a Crystal config YAML file. The client directory is a standard React app created with Vite. Notice the highlighted files. These are the only ones we need to write from scratch. On the server side, index.ts for our Express setup and routes. On the client side, app.csx as the root component, a useChat hook for state management, ChatWindow for the message list, and MessageBubble for individual messages. Let's clone the starter, install dependencies for both server and client, set our API key, and start both dev servers. The server runs on port 3000, the client on port 5173. Here's the entire backend, and it's surprisingly short. We import Express and the Crystal SDK, then initialize Crystal with our YAML config file. The single post chat endpoint does all the heavy lifting. First, we set the SSE headers. Content type is text/event stream, no caching, and keep alive. Then we call crystal.chat with stream set to true, which returns an async iterator. We loop through each chunk with a for-await loop, wrapping each token in the SSE data format. When the stream is done, we send a special done event and close the connection. That's it. The Crystal SDK abstracts away all the LLM provider complexity, model selection, API authentication, prompt formatting. It's all in the YAML config. On the front end, the useChat hook is the heart of our app. It manages the messages array and streaming state. When the user sends a message, we append it to state, then start an empty assistant message. We use the fetch API with a readable stream reader, not event source, because we need post support. As chunks arrive, we parse each SSE line, extract the token, and append it to the last message in state. React re-renders on each token, creating that smooth streaming effect. The component tree is clean. App renders chat window, which maps over messages and renders MessageBubble for each one. The MessageBubble component styles user and assistant messages differently. User messages align right with an accent color. Assistant messages align left with a subtle background. And here's the result running in the browser. Watch how the assistant's response streams in token by token. That's the SSE connection at work. The typing indicator appears while we wait for the first token, then disappears as the stream begins. Each token appends to the message in real time, giving users immediate feedback. Try asking a follow-up question. The conversation history is maintained in the React state, and it's sent to the server with each request so the Crystal agent has full context. The UI is responsive, the streaming is smooth, and the entire app is under 200 lines of code total. That's the power of combining React hooks with Crystal's streaming API. Let's recap what we built. An Express backend with a single SSE endpoint. The Crystal SDK handling all AI orchestration and LLM streaming with just a YAML config. A useChat hook that parses SSE tokens directly into React state. And a clean component tree from app to ChatWindow to MessageBubble. For deployment, you can containerize both services with Docker, deploy the client to Vercel and the API to Railway, and store your API keys as environment variables in production. In the next video, we'll take this chat app further, adding tool use, RAG for document search, and multi-agent workflows. If you found this helpful, subscribe and hit the bell so you don't miss it. See you in video 3.4.